Welcome everyone, welcome to this video where we're going to take a look at a problem in mathematics. And what we're looking at in particular in this video is how the solution to this particular problem actually develops. So it's not the specific problem, it's not the specific solution to that problem that we're necessarily interested in, but how the solution develops. So the problem that I've chosen is a problem from a sixth term examination paper. Step 2, 1990, question number 6. We're going to be looking at this problem, but really what I want to demonstrate, what I want to illustrate is how the problem solving process works, what kinds of ideas you might need to incorporate into your problem solving strategy, and help you to develop your problem solving skills. So if you are preparing for a step exam, a sixth term examination paper, if you're going to university to do maths or whatever, the past papers, the past step papers are excellent resources for to practice the kinds of problems that you might encounter on a step paper, because they are considerably more difficult than the kinds of problems that you will encounter on your normal maths exams. Of course, it almost goes without saying, but I'm going to say it anyway. Before you go in for your step exam, make sure that you're very well prepared for it. So make sure that you've solved plenty of sufficiently challenging problems, sufficiently varied, on a sufficiently regular basis. Okay, you need to make sure that you've got really highly developed problem solving skills in order to be successful in the step exam. If you don't prepare properly for a step exam, you're going to be in for a right old shock when you get into your exam. By the way, I provide tuition, support, and guidance for people who are preparing for step exams, mathematics admissions tests, A-level maths, A-level further maths exams, and GCSE and IGCSE. If you do need help with preparation for any of these exams, or with your work, or you want help particularly with your problem solving skills, developing your problem solving skills, I'd be very happy for you to get in touch with me. I'd love to discuss your needs, your requirements, and how I can help you. I'd love to help you reach your potential and get to a point where you're able to go into your exams with confidence, knowing that you're going to smash your exams and that you're going to secure a place at whichever college, sixth form, or university, academic institution that you want to go to. Okay, feel free to get in touch. I'd love to hear from you. Okay, so let's get on with the problem. So I've described in some of my previous videos what the step exam entails in a little bit more detail. I'm not going to go through that here. I want to get straight on with the problem really. Okay, so we're going back here to 1990, but even though it's 35 years ago, that doesn't mean that the material is irrelevant. Obviously, the specification has almost certainly changed for mathematics over the last 35 years. Some things that you needed to know for A-level mathematics then is not necessarily relevant now, and vice versa. Nevertheless, as somebody with a high level of interest in mathematics who wants to develop his or her knowledge and understanding of mathematics, this really shouldn't be a problem. Okay, you should be prepared to go above and beyond and to learn things that are potentially non-specification material. If you're not prepared to do that, you really want to question whether doing a step exam, doing mathematics at university is the right thing for you to do. Okay, so let's have a look at this problem. So this involves a lot of inequalities, which in my experience, particularly at A-level, GCSE and A-level, people tend to be quite uncomfortable with inequalities because you may be a bit more comfortable with the notion of equality. But nevertheless, inequalities are a very important aspect of mathematics. And for those of you that are going on to do undergraduate mathematics at university, you will very quickly learn that inequalities are as important, if not potentially even more important to mathematicians than equalities, especially when it comes to, for example, real analysis, and complex analysis. Okay, sip of coffee. Okay, so step 2, 1990. I'll leave a link in the description to this video so you can download the paper for yourself. Question number 6. So what we're told is that the numbers A, B, C, D, P, and Q are positive integers. Okay, so always be really, really conscious of the information that you're given. Okay, if you're told that A, B, C, D, P, and Q are positive integers, you're being told that for a reason. Okay, be very aware of this. This might seem like a trivial thing that I'm pointing out, but positive integers have certain properties. They have certain properties that other categories of numbers don't necessarily have. So it would be different if we said that A, B, C, D, P, and Q were rational numbers or just integers, which means that they could be positive or negative, right? These categories of numbers, they've got different sets of properties. So if you're told that these numbers are positive integers, you need to be starting to kind of focus in on what are the specific properties of positive integers. Okay, and that's not to say that you need to know all of the properties of positive integers, because that's not possible. Nobody knows all of the properties of positive integers. Even the best mathematicians in the world won't know all of the properties of positive integers. You don't need to know all of them, but you definitely need to know some of the basic properties. And it would also help greatly if you know what is meant by a positive integer in the first place. And believe me, it's surprising how often people will try to start setting about solving a problem without even having a sufficient appreciation for what the information means that they've been given. So they can read the words, but they don't necessarily fully appreciate what those words mean. Okay, so A, B, C, D, P, and Q are positive integers. Prove that if B is greater than 1 and C is greater than 1, then, let me get this right, BC is greater than or equal to 2C is greater than or equal to 2 plus C. Okay, so how are we going to do this? Well, here's one of the properties of positive integers that we can potentially rely on. If B is greater than 1, that means that B must be greater than or equal to 2. So B is greater than 1, then B is greater than or equal to 2. That may or may not be useful. Okay, I'm not saying that just because you think of something that it's forced to be useful. When it comes to solving a problem, you will get ideas, you will have ideas, and you need to acknowledge those ideas, even at the risk of them being wrong or not useful to you at this particular moment in time. You still need to kind of acknowledge them. Okay, so don't just expect that because you've written something that you will have to use it. Okay, it's just an observation that I've made. It's something that has sprung to mind that may or may not be useful. Okay, we've also got, therefore, that if C is greater than 1, then C is greater than or equal to 2. Okay, so what does that mean then? It means that B times C, B is greater than or equal to 2 implies that B times, and C greater than or equal to 2 implies that B times C is going to be greater than or equal to 2 times C. Okay, so this is using properties of inequalities. If I know that X is greater than or equal to Y and Z is a positive number, then X times Z is going to be greater than or equal to Y times Z. So I'm using the same kind of idea here. I know that C is a positive integer, and I know that B is greater than or equal to 2. Therefore, B times C is greater than or equal to 2 times C. Okay? Don't ignore these seemingly basic properties of numbers and inequalities and things like that. Okay? So that kind of establishes this part of the inequality, but we've still got this part to go here. Okay, how is that going to work? Well, we could play a similar kind of game, right? C is greater than or equal to 2, but now I'm going to use the property that if x is greater than or equal to y, and z is another number, then x plus z is going to be greater than or equal to y plus z. Okay? Again, it's just a basic property of inequalities. I can add whichever number I want to each side of an inequality, and I preserve the inequality. So c is greater than or equal to 2. That means that c plus c is greater than or equal to 2 plus c. But of course, c plus c is just equal to 2c. So 2c is greater than or equal to 2 plus c. Aha. So bc is greater than or equal to 2c, which in turn is greater than or equal to 2 plus c. Okay, and that establishes the first set of inequalities that I need to prove. Okay, that's easy enough. Easy peasy. Okay. So the next bit is, if A is less than B and D is less than C, and D is less than C, then BC minus AD is greater than or equal to A plus C. I guess another thing to point out is, it almost goes without saying, don't try to pull the wool over your examiner's eyes when it comes to this, when it comes to presenting your solutions and things like that. You will not outfox your examiner, or when it comes to any of your maths exams. Your examiner knows way more about maths than you do, and if you present an argument that is not logically correct and it's not logically valid, your examiner will see straight through it. Okay, so really be as precise as you can and base your arguments in logic as much as possible. Okay, so one of the first things that I noticed here with this was that here we've got strict inequalities. Okay, so strict inequalities are less than or greater than, but here we've got a weak inequality. So weak inequalities are less than or equal to or greater than or equal to. So I've got to make sure that this actually happened in the previous part as well. But I noticed it here, I think, more than I did in the previous part. I need to make sure that I somehow introduce some weak inequalities somewhere. Okay. Because I can't assert, for example, let's say I managed to prove that BC minus AD is greater than A plus C. Let's say I managed to somehow prove this. I'm not saying that this is possible to prove, but let's say I somehow managed to get to this stage. What might happen with some people? Somebody who's sitting the exam, they might think, that's not quite right. I know. I'll just change it to a greater than or equal to sign. Again, you've got to base your arguments in logic. So unless there's a specific reason why you can justify changing an inequality symbol from a strict inequality to a weak inequality, then it's not correct. It's not valid. Okay? If the logic is not there, if what you're doing doesn't point towards the right sort of direction, your examiner will pick up on this. Okay, now it might be acceptable on the other hand if you know that A is greater than okay. No, I was going to say something. I've changed my mind. Okay, so one thing, again, relying on properties of positive integers. We know that A, B, C, and D are positive integers. We've been told that. Then that means that A plus 1 is going to be less than or equal to B. That might be useful. Might be, might not be. We'll find out. And we also know that d plus 1 is going to be less than or equal to c. Might be useful, might not be useful. We'll find out. Okay, so notice that I need BC and I need AD. Okay, so maybe what I can do here is this. Because we're dealing with positive integers, I can multiply through here by c. So I get a plus 1 times c is going to be less than or equal to bc. Okay, so if a plus 1 times c is less than or equal to bc, that means that ac plus c is less than or equal to bc. So that could be useful. Could be, I don't know. And you've just got to be prepared to mess around with things. When it comes to inequalities, sometimes that's all you can do is just play around with the inequalities in various ways until something useful pops out. Okay, there's not a strict way that you need to approach this. It's the same with any problem, really. I would be totally lying to you if I said that there is a systematic way that you can go about solving problems, because there isn't. Every problem is its own problem. It demands its own solution. And this is the point, really. This is where you get the sense of satisfaction when you're doing mathematics, is that you find a solution to a difficult and challenging problem. We're not talking about doing routine calculations, routine things like differentiate sine x and things like this. We're talking about interesting problems where you've really got to dig deep and you've got to spend the time with the problem. You've really got to put your heart and soul into finding a solution to it, because the reward is when you actually find the solution. Okay? At least if you're mathematically inclined. If you're not, then, well, don't do mathematics. But if you're mathematically inclined, then that's where you get your satisfaction from. So, okay, maybe I can do a similar thing here. So notice that I need AD. So maybe if I multiply by A. So I'm using what I'm aiming for to kind of guide me a little bit. And do this. Be prepared to do this. Use what you're aiming for as a target to aim for. It's important that when you're trying to solve a problem that you give yourself some direction, because many, many times what I see is people trying to solve problems. Either they don't understand what they've been asked to do, or they don't understand the information that they've been given. They've got no real clear idea, and they're just kind of going all over the place, zipping all over the place, and there's no direction to what they're doing. This is not a good situation to be in. It does happen sometimes, but if it's happening too much, you've got a real problem. You've got a real issue. You need to learn to try to give yourself some direction and accept the fact that the direction that you give yourself might not be the right direction. That's just how it is. Okay, but let's carry on with this. So we get d plus 1 times a is less than or equal to ac. So that tells me that AD plus A is less than or equal to AC. Now this is looking good to me. This is looking good because I've got the AD, I've got the A, I've got the BC, I've got the C. I've got this AC which doesn't appear up here, but I think I'm going to be able to get rid of that actually. Because what I can see now is that if I go for this first inequality, I get that AC is going to be less than or equal to BC minus C. So subtract C from each side of this. Again, properties of inequalities. X is less than or equal to Y. X minus Z is less than or equal to Y minus Z. And it doesn't matter whether Z is positive or negative here, by the way. And also, I get here, I've got that AD plus A is less than or equal to AC. So that means then that AD plus A is less than or equal to BC minus C. So this is looking good because now I can subtract AD from each side and add C. So I get A plus C is less than or equal to BC minus AD. So it's the right inequality, it's just written the opposite way round, which is fine. But I've proved this inequality. Okay, so what I did here was I was using what I've been given to aim for as something to guide me, to kind of try to figure out what I needed to do. So these weren't random things that I just happened to think of. These were based on what I see here. Okay, I was looking at this and I was trying to find a way to get to these particular quantities, B, C, A, D, and so on and so forth. Okay. Right, so that's that done. No problems there. By the way, with this, there's not some. How many are there? There's 4 inequalities to prove, or four steps to 4 parts to this problem. There isn't as much continuity as there normally is. So once you've done one part and you move on to the next part, really you're done with that part. So there's it's quite unusual in that respect that there's kind of a lack of continuity. It's just a series of inequalities that you're proving. So now we've got A over B is less than P is less than C over D. That's the data that we're given. And if that's the case, prove that BC minus AD, not B minus C, BC minus AD times P is greater than or equal to A plus C. Okay, so again, maybe try to base what it is that you need to do, or what you might possibly, what might be useful on what it is that you're aiming for here. So going up to these, we know that therefore that A over B is less than P. So that means that A is less than BP. And we've also got that P is less than C over D. So that means that DP is less than C. Okay, so A is less than BP. That means that A plus 1 is less than or equal to BP. And DP plus 1 is less than or equal to C. So we're using this trick again, that if we've got a strict inequality, we know that A, B, C, D, P, and Q are integers. So if we've got one integer is less than another integer, and it's a strict inequality, then that means that the first number plus 1 is less than or equal to the second integer. Okay, so okay, we've got that. And if I think about what I'm going to get here when I expand this out, I'm going to get BCP and I'm going to get ADP. So that kind of gives me a bit of a clue as to what I need to do here. Multiply each side by C. C is a positive integer, so I preserve the inequality. So I get AC plus C is less than or equal to BCP. Here, multiply through by A, and I get ADP plus A is less than or equal to AC. And this is going in more or less the same direction as the previous part, okay? Because now I can write this as AC is less than or equal to BCP minus C, but I also know that AC is greater than or equal to ADP plus A. So that means, therefore, that ADP plus A is less than or equal to BCP minus C. Right, we're on to a winner now. BCP minus ADP is greater than or equal to A plus C. So A plus C is less than or equal to BC minus AD times P. Okay, again, it's the right inequality. It's written the wrong way around, but probably what I would do in the exam, just to be on the safe side, I would just rewrite the inequality the correct way around, just to emphasize that it is this inequality. You might think, well, surely it's obvious, it's trivial, right? If you've got this, then that. okay, but spoon feed things to your examiner. Just show that for the couple of seconds that it takes to rewrite it out, just write it out. And then there's no ambiguity. There's no risk that you're going to lose any marks or anything like that. You can put your mind at rest and you can move on. Okay, so that was easy, I guess. So then we're on to the next part 4. So now we've got that A over B is less than P over Q is less than C over D. Let me make sure of that. Yeah, okay. So we need to prove now that P is greater than or equal to A plus C over AD, BC minus AD, over BC minus AD. BC minus AD. And Q is greater than or equal to B plus D over, I think it's still BC minus AD. Let me check. Yep. Okay. So if this, then these. Okay. Right. So A over B less than P over Q. I didn't have too. I'm not trying to flex or anything when I say this, but I didn't have too much difficulty with these particular problems. Now, I've got a big advantage in the sense that doing undergraduate maths, you get a lot of practice dealing with inequalities. So you start to, in many ways, think in terms of inequalities. But I know that inequalities are something that a lot of A-level students can have some difficulty with. Okay, so what I'm hoping to do here is to kind of give you some ideas about ways that you might be able to deal with inequalities. So what do we get from this? We get that AQ is less than BP. And again, we've got these weak inequalities here. So straight away, I'm just going to slap in the 1 there. AQ plus 1 is less than BP. And P over Q less than C over D. We get that P times D is less than C times Q. Again, all of these are positive integers, so we don't need to worry about the inequality symbol flipping around or anything like that. It's very straightforward. And that means that P times D plus 1 is less than or equal to C times Q. Okay? Right. So what I'm wanting to do, on the one hand, is to, with these two inequalities, eliminate Q, so that I get an inequality that just involves P, and then, on the other hand, start from scratch and eliminate P, so that I've got an inequality that just involves Q, that hopefully will rearrange to this and this respectively. So let's get rid of Q first. So how can I do that? Well, I've got A here and I've got C here. So ACQ plus C is going to be less than or equal to BPC. And also PDA plus A is going to be less than or equal to ACQ. So if I subtract C from each side of this, I get that PDA plus A is going to be less than or equal to BPC minus C. So therefore, P times D times A plus A is going to be less than or equal to B times P times C minus C. I think this is going in the right direction here. So subtract P times DA from each side, add C to each side, take the P out as a common factor, minus DA, or AD, whatever, A plus C, and we get P is greater than or equal to A plus C over BC minus AD. So that's the first inequality done, and it's going to be a very similar thing that we need to do for the Q. Okay, so Q, it's going to be, what have I got here? I've got CQ, it's P that I need to eliminate. So multiply through by D, you get ADQ plus D less than or equal to B d times p. Yeah, okay. And also multiply through here by what? By b. So I get b dp plus b is less than or equal to bcq. And it's going to be basically the same thing, right? So ADQ plus D is less than or equal to BDP is going to be less than or equal to BCQ minus B. And just basically follow the steps that we had to get P. So we can get rid of this bit in the middle here. Add B to each side. B plus D is going to be less than or equal to BCQ minus ADQ. Take Q out as a common factor, divide through by BC minus AD. I suppose one thing that might be worth checking, just double checking, is that B times C is going to be, BC minus AD is going to be greater than 0. It's going to be positive. That's not too difficult really to just double check, because if we know that A over B is less than C over D, then we get that AD is less than BC, so therefore wrong way around. BC minus AD is greater than 0. And that I didn't actually do that. Maybe I was a little bit careless when I went through my solution, but that would be something that would be worth pointing out as well. Just that BC minus AD is going to be greater than 0. Because then when you divide through here by BC minus AD, you're definitely dividing through by a positive number. Okay, so and that gives us the solution to that particular problem. There is one last part, and it's kind of an unusual thing. Kind of just follows on a little bit from this, but it's a very strange problem, really. So hence find all fractions with denominators less than 20 which lie between 8/9 and 9/10. So we've got 8/9 less than P over Q is less than 9/10. So that means that A is equal to 8, B is equal to 9, C is equal to 9, D is equal to 10. So plug these values into these inequalities, we get P is going to be greater than or equal to 8 plus 9 over BC 81 minus AD, which is 17. And similarly, Q is going to be greater than or equal to B times D over, again, 81 minus 80, which is 19. Okay, so the only fractions that are going to satisfy this set of inequalities are fractions such that P is greater than or equal to 17 and Q is greater than or equal to 19. Okay, obviously between 8/9 and 9/10 there's going to be an infinite number of possible fractions. Okay, an infinite number of rational numbers that satisfy this inequality. But what we do know is from what we've proved is that the numerator must be at least 17 and the denominator must be at least 19. So, okay, let's have a look. What are the possibilities then? Well, if we're looking for denominators less than 20, that means that, well, let me just write these up here. That means that the only possible denominator that we can be interested in right now is 19. Okay, so the possible numbers are 17/19, 18/19, 20/19, 21/19, and so on and so forth. Okay, so what we need to do is just, well, we know that 17/19 is going to be in between 8/9 and 9/10. We can double check that, by the way. So let's do 8/9, 17/19 minus 8/9. Bearing in mind, I think you might have been allowed to have a calculator in this particular step exam, but besides, we don't really need a calculator. So that's going to be 17 times 9, 170 minus 17, 153. 19 times 8. I've lost track. That's going to be 152. Over whatever 19 times 9, 190, 171. Which is 1 over 171, which is greater than 0. So yeah, 17/19 is greater than 8/9, which is what we expected. 9/10 minus 17/19 is going to be equal to 19 times 9. I've just done that. 171 minus 170 over 10 times 19, 190, which equals 1 over 190, which again is greater than 0. So yep, 17 over 19 definitely lies between 8/9 and 9/10. So that's definitely one that we're interested in. What about 18/19? Well, obviously 18/19 is greater than 17/19, so it's definitely going to be greater than 8/9. But is 18/19 greater than, is it less than or greater than 9/10? Let's find out. 18/19. 19 times 9, I'm sick of doing this now. 19 times 10, 190, 171 minus, okay, so 190. That's going to be less than 0. So that means that 18/19 is greater than 9/10. Okay, so it looks like the only fraction that has a denominator less than 20 that is between 8/9 and 9/10 is this one, 17/19. Okay, that's what I mean. It's a bit of an unusual problem. That it's kind of an anticlimax, really. What might have been better, in my opinion, was if they'd said, denominators less than 22 or something like that, because then you would have had to consider 17/20, 18/20, 19/20, 17/21, 18 over 21, 19 over 21, and so on and so forth. So you'd have had a bit more work to do in that case. But yeah, that's it. It's 17/19. That's the only fraction, but you need to justify it. Okay, so it wouldn't suffice for you to just derive these inequalities. P is greater than or equal to 17, Q is greater than or equal to 19, and just say therefore 17/19 is the only fraction. Or maybe you'd be naive enough to say Q must be equal to 19 because you recognize that the denominator has to be less than 20, but just assuming that any numerator greater than or equal to 17 is gonna suffice. What this is not saying is that any and all numerators greater than or equal to 17 and denominators greater than or equal to 19 will satisfy this. This is just P must be greater than or equal to 17 at the very least. It's a necessary condition, but it's not a sufficient condition. Okay, so you've got to recognize that just sticking any two numbers P and Q, so if you went for 24 over 21, for example, both of these satisfy this inequality, but they don't satisfy, this fraction doesn't satisfy this inequality. Okay, so that's the end of this particular problem. So it gives you a bit of practice with dealing with inequalities. If there is anything that you'd like some clarification on with this video, then please leave a comment in the comments section. I'll be happy to get back to you. Please hit the subscribe button to show your support for this video. So I don't make any money from these videos. I make these videos because I enjoy making them, and I want to help you develop your problem solving skills so that you can get the best grade that you can on your A-level maths exams, your A-level further maths exams, your STEP exams, your MAT exams. So please show your support by hitting the subscribe button and hitting the like button for this video. I'll be uploading plenty more videos over the coming weeks and months for STEP, MAT, and some other things as well. So keep checking back to this channel, see what updates there are. That brings us to the end of this problem. And it brings us to the end of this video. So thanks a lot for watching, guys.